Hey guys, it's Mr. Chu, and here's what you're going to learn today. By the end of this video, you should be able to identify key features of rational functions. So we have this function, looks kind of ugly, but we actually have enough tools to find all of these key features. And one of the first things that I suggest doing is factoring your equation. Now you'll notice that you have a common factor in your numerator and denominator. So I'm going to go ahead and simplify. The remaining factor on your denominator is x minus 4, and that's going to be your vertical asymptote. So x minus 4 equals 0, and that's actually at the line x equals 4. Now the terms that we simplified, x minus 3, that's going to be your whole. So there is a whole at x equals 3. Now a whole is a specific coordinate, so it does have an x and what is supposed to be a y value. Now I'm saying supposed to be because a whole is a discontinuous point, so it's not actually there, but we actually have to figure out where it would be. We'll take the remaining factors, which are x minus 1 over 4 times x minus 4, and we're going to substitute in 3 and substitute it into the simplified rational expression. So we wind up getting 3 times 3 minus 1 over 4 times 3 minus 4, which is going to be 3 times 2 over 4 times negative 1, which is going to be negative 3 halves. So we actually have a whole at 3, negative 3 halves. So the domain is going to be all real numbers where x cannot be equal to 4 and x cannot be equal to 3. Based on the degree of the numerator and denominator, we know that this function does not have a horizontal asymptote. It does, however, have a slant asymptote. And the way we find our slants is by using polynomial long division. So I'm going to go ahead and get through this long division. Okay, so that's a lot of work. But what we're really focused on is our quotient. And so we have 1/4 x plus 3/4. And so this line is actually our slant asymptote. So the equation y equals 1/4 x plus 3/4 is what our graph is going to approach. And so for our range, x-intercepts, y-intercepts, and end behavior, we can actually just look at our graph. So what I've done already is typed in the equation to Desmos, and what we're going to do is look at some maximum and minimum values to help us figure out our restrictions on our range. So you'll notice that there's two parts. You got this bottom part that's going off to the left, and then the top part which is going up to the right. Our graph down here appears to be going towards negative infinity. But there is a maximum value, and the maximum value for our range is 0.018. So that means for our range, we're going to go from negative infinity until 0.018. But since there's two parts to this graph, we know that we have to start at another value. And that's going to be at this minimum, which is 3.482. So from 3.482 until positive infinity. For our x-intercepts, we're trying to figure out where does our graph cross our x-axis. And in this case, we have two spots, 0, 0, and 1, 0. Algebraically, we can tell based on our simplified rational equation. We have x times x minus 1. And so we want to figure out when our numerator is equal to 0. So we'll set that equal to 0 and use zero product property to solve. And we'll get a 0 and we'll get 1. For our y-intercept, we can look at our graph. In this case, we know it's 0, 0. But algebraically, what we can do is say, when we plug in 0 for all of our x's, what's our output value going to be? So what's 0 minus 0 plus 0? 0, right? As far as end behavior goes, we want to look at the left side of our graph. What are we approaching, and what are we approaching on the right side of our graph? If we zoom out for a really long time, you'll see that our output values continue to decrease on the left, and they continue to increase on the right. So it is said that as x goes to negative infinity, f of x is going to negative infinity. Again, because on the left side of this graph, the output values continue to decrease, and they decrease forever. On the right side of our graph, all of the output values continue to increase. As x goes to positive infinity, f of x also goes to positive infinity. Now I'd just like to show what the slant asymptote looks like. And so I've already typed in the equation of the line, and I'm going to turn it on, and we'll see that your graph is going to kind of run along this line. It's going to get really, really close, and towards the end it's going to just really approach this line, and on the left side it's going to do the same. As for finding key features, that's it.